Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the second unit of Basic Electronics, that is Applications of Diode. So in this video, we will learn about filters. Filters are electronic circuit used along with the rectifier in order to get a pure ripple-free DC voltage. A filter minimizes the undesirable AC component, that is ripple, from the rectifier output. Function of filter: to remove the ripple from rectified output voltage, to allow pure DC voltage to reach the load, to improve the ripple factor of the rectifier. So, filters are used to reduce noise, that is AC component, that is ripples, which are present in the rectified output. So this is the rectified output and this is the output of a filter circuit. Now, types of filter. Filters are classified depending on the components used and depending on the configuration in which they are connected. Some of the important filter types are as follows. First is shunt capacitor filter, series inductor filter, LC filter and pi filter. First we will see shunt capacitor filter, also called as capacitor input filter or C filter. The shunt capacitor filter is used to reduce the ripple contents in the output of a rectifier to obtain a pure DC voltage. A full wave rectifier along with a capacitor input filter is shown in figure. C is the filter capacitor which is connected across the load resistance RL. Figure shows the full wave rectifier with capacitor input filter. The filter capacitor is connected across, that is in shunt with the load. This filter is called as a shunt capacitor filter. So here you can see this capacitor will be connected parallel with the load. So this is called as a shunt capacitor filter circuit. Operation of full wave rectifier with shunt capacitor filter. So here this is the graph which shows the shunt capacitor filter output. Here diode D1 is conducting. In this portion diode D1, D2 will be non-conducting. In this portion again diode D1, D2 is conducting, and in this portion both the diodes are off condition, and here again diode D1 is conducting. Operation in the interval 0 to A. The initial voltage on the capacitor C is assumed to be 0. In the first positive half cycle of the supply, diode D1 is forward bias and start conducting. Diode D2 is reverse bias and act as an open switch. Diode D1 supplies for the charging current of the capacitor and the load current. Capacitor start charging through D1, and at the end of this interval, that is at A, it charges the peak value of the secondary voltage Vn. At point A, voltage on capacitor is equal to maximum voltage Vm. After the point A, the instantaneous secondary voltage start reducing as shown by the dotted waveform of rectifier output. This will reverse bias the diode D1. Hence, at A, the diode D1 is turned off. Now next, operation in the interval of A to B. During this interval, voltage on the capacitor is higher than the rectifier output as shown by dotted lines. Hence, D1 and D2 both remain off. The capacitor discharges exponentially through the load resistance RL. As the value of RL is much higher than RF, the capacitor discharges slowly. Discharging time constant is RLC. The value of C is very large in order to make the discharging time constant as large as possible. This will reduce the ripple content in the output voltage. Now next operation in the interval of B to C. At point B, the instantaneous rectified voltage is equal to the voltage on capacitor, and after point B, it is greater than Vc. Therefore, diode D2 start conducting at instant B. The capacitor charges through D2, and at the end of this interval, that is at point C, the voltage on capacitor is again equal to plus Vm. Due to this, D2 is reverse bias and stop conducting at point C. Now next operation in the interval of C to D. The operation in this interval is identical to that in the interval A to B. Now next type of filter is series inductor filter, also called as choke input filter or L filter. Now this is a circuit diagram for which shows the full wave rectifier with series inductor filter. In series inductor filter, the inductor, that is choke L, is connected in series with the load R. The property of an inductor is that it opposes any change in current through it. Is being used here to reduce the current ripple in the output of the rectifier. Now, operation of full wave rectifier with series inductor filter. The diode D1 and D2 conducts alternately in the positive and negative half cycle to produce the unidirectional current through the load. Due to the inclusion of inductor L in series with the load, the current ripple reduces to a great extent, and the load current is smooth. Higher the value of inductor is, lower will be the peak-to-peak ripple in the load current waveform. The load voltage waveform is same as the load current waveform. Thank you.